Alrighty, so let's try another example of an improper integral of type 2. This one that I have on the screen right now is improper because, well, it's not continuous. The integrand is not continuous at x equals 2, right? And 2 is in our interval. Our interval's from 1 to 3, 2 is in that interval. So it's not continuous at x equals 2. So what we're going to do to evaluate that is to break it up from 1 to 2, excuse me, and from 2 to 3. If either one of these two integrals diverges, then the integral in question, the integral we're working on, diverges. However, if both of them converge, the integral that we're looking at is going to be defined to be the sum of those two integrals. Okay, so we have to evaluate these separately. But you might notice that it's the same integrand, so it's the same sort of process of evaluating them, but we'll evaluate them separately anyway. So let's look at the first one. So let's call that 1. We're looking at the integral from 1 to 2 of x dx over x minus 2. And it's continuous everywhere except for at 2, so we can break that into the limit as t goes to 2 from the negative side, right? Because I'm going from 1 to 2, so t is going to be less than 2 of the integral from 1 to t of x dx over x minus 2. So now we got the issue of evaluating that integral. So we could do it with fancy u substitution, u equal x minus 2, right? Just something to sort of point out. U equal x minus 2. That's going to be x is equal to u plus 2, or dx u plus 2. Dx is equal to du. Or I'm going to break it up in a different way, just use a little bit of algebra. I'm going to write that as limit. Remember, in a lot of these problems, there's more than one approach to it. And I'm just noticing if I subtract 2 and add 2, I can break it up into 2 fractions. So I can break it up into x minus 2 over x minus 2 plus 2 over x minus 2. For some reason it wants to connect my minuses to my 2's. Dx. And that could be the limit as x goes to 2 from the negative side of the integral from 1 to t. Oh, that's not x goes to 2. That is t goes to 2. Let's erase that and replace it. 1 plus 2 over x minus 2 dx. And now we can integrate that. That's the limit as t goes to 2 from the negative side of well, when I integrate that, what do I get? I get t plus 2. Oh, I'm integrating with respect to x. Start it again. And if I integrate that, I get x plus 2 ln x minus 2. And of course, the derivative of x minus 2 is just 1, so I have no constant to worry about there. And that's from 1 to t. And so this is the limit as t goes to 2 from the negative side of, when I plug in t, I get t plus 2 ln of t minus 2. When I plug in 1, I get 1, so I'm subtracting this off. 1 plus 2 ln of 1 minus 2. That's ln of absolute value negative 1. That's ln of, well, let me write this out. What is that going to be? Of course, yeah, you got it. That's going to be ln of 1, which is just 0. So that's just going to 0 out. Okay, so let's bring this down there. This is now the limit as t goes to 2 from the negative side of t plus 2 ln of absolute value t minus 2 minus 1. So what's happening here? Well, t, of course, is just going to 2. That's not an issue. So t minus 2 is going to what? It's going to 0. So ln of 0 is, well, as it goes to 0, that's going to minus infinity. So I get minus infinity, 2 minus 1. This is going to go to, this is going directly to minus infinity. So what does that mean? That means it diverges. Diverges. So the first integral, the first one that we were working with, this one right here, this diverges. So what does that mean? That means the entire integral we were working with, this, diverges. So the whole thing diverges, and we're done.